Welcome to the session on trigonometric ratios, the sine rule. The objectives for this session are to apply the sine rule to find a missing side or angle. Before we launch into this session, let's recap on Pythagoras' theorem, as this will help us to prove the sine rule. In Pythagoras' theorem, consider a right-angled triangle. The side opposite the right angle is the hypotenuse. Let's denote the length of the hypotenuse by C, and the length of the other sides by A and by B. Then A squared plus B squared equals C squared. Let's take a look at an example. We can apply Pythagoras' theorem to the example on your screen to find the missing side. Notice that A equals 3 and B equals 4. So if we square A, which is 3 squared, and square B, which is 4 squared, and add them together, we should get the length of the third side squared. So since 3 squared plus 4 squared equals 5 squared, we have that the length of the third side is 5. Let's now take a look at trigonometric ratios. In a right-angled triangle, three trigonometric functions are sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. Now let's consider the sine rule. The sine rule can be used to work out missing sides or angles in triangles. Consider the diagram on your screen. Consider also the version of the sine rule shown on your screen. It can be used to find the length of a missing side. In the diagram, do ensure that each side has the same letter as the angle opposite. So little a is opposite capital A, the angle, and little b is opposite the angle capital B, and little c is opposite the angle capital C. Let's now prove the sine rule. Consider the version of the triangle shown on your screen. We're going to drop a perpendicular from C to AB, as shown. The length of AB is little c. We're going to use standard trigonometric rules to prove the sine rule. So in triangle CBX, shown on your screen, sine B equals h over A. Rearranging gives us that h equals A sine B. In triangle CAX, which has been highlighted, sine A equals h over B. And rearranging gives us that h equals B sine A. So therefore, A sine B equals B sine A, as shown. And this implies that A over sine A equals B over sine B. Similarly, we can show that A over sine A equals C over sine C if we drop a perpendicular from B to AC. And therefore, A over sine A equals B over sine B equals C over sine C. We have therefore proved the sine rule. The sine rule, as expressed above, can be rearranged to make it easier to find the length of a missing angle. In this form, sine A over A equals sine B over B equals sine C over C. Both versions of the sine rule have been presented on your screen. Let's apply one of these versions to an example. In this example, we are required to find the size of angle CAB, and hence find the size of angle BCA. First, let's label all the sides correctly so that we can apply the sine rule. Little a goes opposite capital A, little b goes opposite capital B, and little c goes opposite capital C. And now let's solve. We're going to use the version of the sine rule highlighted in order to calculate the angle. So since sine A over A equals sine B over B, we can substitute in the values. A equals 1.4, B equals 7.4, and sine B equals sine 60. Rearranging gives us that sine A equals 1.4 times sine 60 over 7.4. And calculating this gives us that this value is equal to 0.16384. And therefore angle A, or more precisely angle CAB, is equal to 9.4 degrees. Now let's solve the second part of the example. From the first part of the example, we had that angle CAB equals 9.4 degrees. And therefore, angle BCA is simply 180 degrees minus angle CBA minus angle CAB, as angles in a triangle add up to 180 degrees. And therefore, angle BCA equals 110.6 degrees. Now let's take a look at another example. We are required to find the length of side B. So therefore, we're going to use the highlighted formula. So let's solve this example. Rearranging the sine rule implies B equals A over sine A times sine B. And then plugging in the values gives us B equals 6 over sine 53 times sine 37. B is from here, A is from here, angle A is here, and angle B is here. And so if we calculate these on our calculator, we obtain B equals 4.5. Now, the situation is actually a little bit more complicated. Sometimes we can have two possible solutions, because sine theta equals sine 180 degrees minus theta. So for given side lengths B and C and given angle C, the triangle can be drawn in two different ways. Either triangle AB1C or triangle AB2C. Angle AB1C is obtuse and angle AB2C is acute. Let's confirm both of these two solutions. Consider the graph of y equals sine x. It looks something like this, between 0 and 180 degrees. Observe the angle theta shown on your screen. Sine theta is the value that corresponds to it. However, as you can see, we've extended the line for sine theta, and it cuts another point on the graph as well. And it's this value here, 180 degrees minus theta. And therefore, this confirms that there can be two possible solutions. Let's now take a look at an example. In triangle ABC, AC equals 4 centimeters, AB equals 2.1 centimeters, and angle ACB equals 30 degrees. Work out two possible values of angle ABC. Let's have a look at what this triangle could look like. There are two possible ways of presenting this triangle, AB1C and AB2C. Here we've added the side lengths. Now we've added the values. So AC of course equals 4 centimeters, AB equals 2.1 centimeters, and there are two ways of obtaining AB, either with an obtuse angle or with an acute angle. And of course angle ACB equals 30 degrees. We are required to work out two possible values of angle ABC. Let's look at the sine rule. Sine B over B equals sine C over C. Plugging in the values gives us sine B over B equals 4 equals sine C equals sine 30 degrees over 2.1, which is the length of C, or little c. And therefore, calculating on your calculator should give you sine B equals 0.97561. And if we inverse sine, we obtain 77.3 degrees. This is, of course, an acute angle, as shown. What about angle AB1C? We can find this by subtracting 77.3 degrees from 180 degrees. To give us B1 equals 102.7 degrees. This brings us to the end of this session. If you have understood its contents, you should be able to apply the sine rule to find a missing side or angle. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.